We're now ready to go ahead with an example showing how we can calculate the Fourier coefficients, the a sub v, the a sub n, and the b sub n, for a periodic waveform. The periodic waveform we're going to do first of all is this simple square wave, where its period is 0 to t, so it's got a period of t. During the first half of the period, from 0 to t over 2, the function equals positive e sub m, and during the second half of the period, it equals negative e sub m. So this is a piecewise continuous function defined like that. A sub v, we have seen, is calculated using this formula, which for this f of t or v of t, this function, is going to be 1 over t times the integral from 0 to t. Now, 0 to t over 2, during that interval, the function is v sub m dt. Then we'll have the second part of the period from t over 2 to t of negative v sub m dt. Now when we do the integration, we have still this 1 over t term out in front, multiplying. Now the integral of v sub m dt, that's just v sub m t evaluated from 0 to t over 2. And this term over here is going to be a negative v sub m t evaluated from t over 2 to t. Now going ahead and evaluating at these limits, factoring out the v sub m, we've got then v sub m over t times, at the upper limit we have t over 2, minus this at the lower limit, which is 0, minus, now we've got this minus this term at the upper and lower limits. At the upper limit we have then t, lowercase t evaluated at uppercase t is t, minus t evaluated at t over 2. Now cleaning this up just a little bit, this gives us v sub m over t times t over 2 minus t, minus a minus is a plus, minus a minus is a plus t over 2, which when we combine them we get t over 2 plus t over 2, that's a positive t minus t. It turns out that for this waveform, a sub v equals 0. What does that mean? Well, a sub v is the DC component. It's the average value of this waveform. Well, this waveform spends as much time at positive e sub m as it does negative e sub m. The average value of this waveform, or its DC component, is in fact 0. So a sub v equals 0 for this function.